Welcome back to another episode of Matrickz Tech Talk. Today we have someone very special all the way from Jerusalem, Nat Meron from CYBERSECURITY. Nat, welcome to Matrickz Tech Talk.
Thank you, Hasan. Thank you for having me. I'm really happy to be here.
Amazing. So a little bit about Nat. Nat started his first startup at the age of 20. He serves the Israeli intelligence. He also is an international speaker and very passionate about automotive security. So Nat, why don't you tell our audience a little bit about yourself, your passion and your background, and how did you get started with CYBERSECURITY?
Originally, I studied electrical engineering, so all the way to electronics and the basic stuff. And actually, I used to be the TA for intro to networks and network security and the operating systems and how they are built. So went into CS. And yes, afterwards I joined the army and I served at the intelligence, focused on cybersecurity. So that's where I think my romance with cyber started. And after my release, actually, I had my own startup, which we tried to do cloud and edge devices. And one of the VCs that wanted to invest in us was our crowd, which is one of Israel's largest VCs. After that startup shut down, then our crowd actually approached me and told me, hey, we have an amazing startup that we just invested in called CYBERSECURITY, just a seed round. And we think you'll be a very good match with them. And 3 days later, I was in Jerusalem. I used to live in Tel Aviv. I came to Jerusalem. We sat in the incubator of Labs 02 in Jerusalem. And, they presented me the problem. And, having a CEO like Michael, which is a veteran in embedded security, and Isaac, which is our VP R&D, which has like 20 years of managing project in this area, and see what is the current landscape and how we can contribute to the ecosystem and build products that really fit the automotive industry needs. And at the end of the day, we knew that we're going to continue to do this together. And 2 years afterwards, yes, I guess it was a good match.
Sounds like it. Amazing. I'm super excited. So I can't help starting with a very provocative question, if you will. So we have seen massive acquisitions in automotive cybersecurity. One famous acquisition was Argos, one Tel Aviv startup that was bought by Conti reportedly for $500 million. And we've seen a recent McKinsey white paper where they predicted the market to be multi-billion-dollar market today. And in 5 years, it's going to be even more. As an industry insider, I work in the Matrickz, my company works as a service provider in the automotive cybersecurity domain. We do not feel that much of attraction yet in the market. On the other hand, we see the Tel Aviv-based startups are showered with venture capital money. Can you do you also feel that imbalance, and can you explain us this imbalance and why is that so?
Yes, so I think that from a market point of view, until 2020, there was definitely lack of demand in the market. So the balance started there and a lot of money spent by VCs on automotive cybersecurity. However, we see that 2020 is the key year or the change year for automotive cybersecurity. Because I think after 8 years of education that the market has been through, both internally in organizations, building their cybersecurity capabilities, and also by startups that are pitching and explaining and contributing their own knowledge to the ecosystem. The demand is here because of that, and also because regulation is here. So mid-February, I think it was February 17th, because I just gave a lecture at Move that day and about the security lifecycle and the ISO 21434, and the first draft was published that morning. So it was really amazing to see the most, usually it's like the most boring lecture, right? Who wants to hear something about standards in such a conference? And the hall was packed because the ISO was just published, the first draft. So regulation is here, and with the education that the industry already been through, we see the demand starting to increase. And obviously, there was previous demand for the more basic features, so encryption or secure boot, even though you can still see debates between the automotive engineers arguing that the secure boot will mess with their timing, yes, and reduce the quality of product. So in some areas in the vehicle, we're still there. But we see the demand. We see concrete contracts that require more advanced security features, so active security, like network IDPS or firewall, if you want to call it like that, and endpoint protection. And it's actually interesting because you see it both from the OEM that wants to protect the vehicle, because obviously he is facing the consumers and he wants to have a secure product. But also from the tier one's point of view, they are getting ready to it, both to meet the OEM requirements, but also they are aware that if there will be an incident, they might be found liable. So you see tier ones also preparing and implementing some cybersecurity measures because they want to provide a good solution. And it's like in the consumer, right? When you buy Apple iPhone, everybody knows that iPhone is secured, right? And accordingly, the quality of iPhone is considered higher. So I think tier one automotive, what we see, are starting to think like that. Still a way to go, obviously, but we see how it happens.
Fascinating. You mentioned a lot of stimulating points. I'm going to start with one. You mentioned active security, and I totally agree with you. Some passive security features like some challenge response protocols, some crypto at a certain level based on HSM and firewall, that kind of things where their OEMs were putting some requirements in the ECU development process. However, like you rightly mentioned, active security, an intrusion detection system, for example, I couldn't really see any practical a series production of that yet. My question is, can you, for our audience, first of all, elaborate a little bit? What would you consider as passive? What would you consider as active? And then come to the point, why aren't we there, the active security bit yet? Because in my opinion, passive security is some kind of defense, but as long as you don't actively look for it, there will be zero-day vulnerabilities, there will be zero-day exploits, and those things can only be handled if you have an active security mechanism, also a team working for you, managing incidences and so on.
First of all, a vehicle is it's a complicated system. We all understand that. And I think it's fair to say that there's not going to be one solution that protects from everything, right? You know it, yes. If someone will tell you you have this magical solution that you're going to put on your gateway or one of the main components, and it's going to protect the whole vehicle from all the different attack vectors, you're going to laugh. There is no such thing. And in a complicated system like a vehicle, we're going to have a security in-depth strategy and create several layers of protection. So passive security, if we can call it like that, like encryption and secure boot, are the pillars for security, right? I can tell you that some of C2A solutions, we assume that there is secure boot. Because if there's no secure boot in place, then someone is going to just run his own image, and our security worth nothing, right? It's just going to delete us. I think it's about creating several layers. Now, when you look at active security, you said it exactly right. If you have zero-day vulnerabilities, you have to deploy some more advanced security measures that will protect your vehicle from such attacks. I think the most classic use case now is if you look at the TCU, right? It has those beacons, right? Bluetooth beacons, and different drivers and applications that are talking to the outside, right? The extranet. They have an interface which is accessible. It has to be protected in a more advanced mechanism because the attack surface there is significantly higher or bigger. So we cannot assume that a simple encryption mechanism, even if it's the strongest encryption mechanism, yes, but the handshake can be hijacked or can be attacked, or you can leverage that beacon and exploit a vulnerability that just been published. It's like saying that I use OpenSSL, I'm secured. Now, what you did is that you secured the channel, which is extremely important. Yes, it's a pillar to our security. But having said that, we have to make sure that OpenSSL itself is secured, right? Because there have already been several vulnerabilities published in that library. So someone might actually exploit OpenSSL itself to run his own code on that endpoint.
I totally resonate with you what you're saying. So, like the statement that you started with, I agree with that. I mean, passive security are the pillars. SSL are the pillars, but it's not going to save you from the attacks. And there's this statement that if there is a person out there who has built the system, there is another person out there who can unbuild the system or break the system. This is axiomatic. Now, the thing that I want to go to, so we have the technology sphere. Yeah, in automotive, we have the technology sphere, we have firewalls, we have intrusion detection system, we have the cryptos, we have HSM, we have a standard. AutoSAR is standardizing the interfaces at a code level. So we made this progress. Can you tell me a little bit about, in terms of series production, what kind of deployment have you seen so far with these technologies that I've mentioned? Or if I missed something, can you please add?
Yeah. So no, I can't provide all the data that we are aware of, obviously.
Yeah.
But I think in general, the industry is at the passive phase currently. So what you'll see
Agreed.
on the road is, and in the next couple of years, is mostly passive. But we now see how the industry is going towards active. And we actually have one client that is already planning to take a C2A solution and put it on the road. The start of production is end of this year for active measures. But that's a very mature client from my point of view. Yes, it's not the common manufacturer in the industry. So I think we're mostly passive right now, early birds of active. And I think by the years 23, 24, we'll see much more active measures out there inside the vehicle.
Do you think the legislators are somewhat slow in this? While we didn't have a standard, so the legislators did not have anything to point toward. Do you think the standard, when it's published officially, not the draft, released officially, do you think that might accelerate the growth in the market?
Yeah, so by definition, legislation and regulation are very slow. I can tell you that almost every player in the ecosystem is already preparing for adopting the ISO standard, because the Work Group 29 already provided some more concrete guidelines in adopting the standard, and the EU accordingly provided timeline for adoption, and that mid-2022 we have a very serious milestone of them demanding to have cybersecurity management systems in place for vehicles that are going on the road that year. So, in automotive terms, it's here. That's right. 2 years from now, it's vehicles that are already closed. The power programs are already closed, most of them. So it's here. It took time, but it's definitely here. Standard is guidelines. It's not concrete implementation. So we still have a way to go. But I think that if we have this deadline of 2022, mid-2022 for the EU for adopting cybersecurity management systems, it's a huge milestone for the industry.
Got it.
Because it's an important milestone for OEMs towards adopting more advanced solutions.
Gotcha. I'm also interested in C2A. Can you tell us the product landscape, or what is the mission of C2A? Can you tell our audience a little bit about it and the kind of products that you're offering?
Right. So C2A is a trusted partner for automotive manufacturers to help them secure their vehicles and their components. So we are this independent, neutral partner, and so it means that we can collaborate with anyone in the industry. And our goal is to protect vehicles and the internal systems. So we may collaborate directly with the OEM to help them implement the solutions, or with the tier ones, or guided by the OEMs to collaborate with the tier one. And eventually is to protect the internal systems of the vehicle. So we're like the digital equivalent of airbags for the cyberspace. That's what we do. Now, it's less about being the sexy stuff, like blockchain and cloud, and more about providing the embedded security that you implement in different places inside the vehicle to protect from different attack vectors. Now, what we believe in is that, as I said, there is no one silver bullet solution for automotive attacks. So we provide a multi-layer solution, so it's different solutions that are deployed inside different places in the vehicle. And together, we can provide this multi-layer protection that protects from different attacks.
Mm-hmm. So when you say multi-layered protection, so are you setting protection at the TCU level, gateway level, the vehicle network level, or also in the ECU level? So what are these levels that you're talking about?
Yeah, so if we look at an automotive attack, how it's going to look like, right? We're going to have the first step is going to be penetrating into the vehicle. Mm-hmm. So you have perimeter devices like head unit or the TCU, which have one leg inside the vehicle and one leg to the outside. And that's the entry point for the attacker. So the first step is going to be to try to take over one of these components. Now, if I'm an attacker, once I took over one of these components, I'm going to sniff the vehicle internal networks. I'm going to gather some intelligence, try to understand what's the vehicle behavior. Maybe I did my research beforehand. And then I can either attack the network itself or use it to spread into a more interesting area inside the vehicle. So we call it a lateral movement. So from the head unit, I'll try to get into the central gateway or the ADAS system. Let's say I decided that I want to go to the ADAS because I want to take over or I want to control the vehicle behavior while driving. So I'm going to try via the networks to get to a more interesting endpoint and run my own code there. So then operate some malicious logic or disable the endpoint. So basically 3 steps or group of attack surfaces inside the vehicle. So perimeter, networks, and endpoints. And what we do, we actually provide a solution for each step because you have different attack vectors that require different protection. We can't say that we're going to protect all these different steps with one solution because, it's not possible. It's different styles of attack, different attack vectors, and they require different measures.
So 3 levels you mentioned, perimeters, network, and the endpoints. So for these 3 layers, you are providing different defense mechanisms. So what is the active part in these defenses and what is the passive part in your solution?
So C2A is mostly an active part solution, right? So
Love it.
Our solutions, all of them mostly are active. We have some passive logic, which is the firewalling. It's inside the network IDPS because our clients usually look at it as one solution. So doing the basic filtering and the firewalling and combine that with network IDPS for selected network activity. So that's going to be our network protection solution. And for perimeter and for endpoint, it's active solutions. The reason we did them active is because we are aware that there are passive solutions in the market. We don't think you need to cancel them. We didn't think we can contribute significantly over those solutions. So if, for example, you look at HSM, we didn't think we're going to reinvent HSM. So we think there are decent suppliers in the ecosystem and that the OEMs will probably go with them. And the same goes for secure boot. Today, you can walk into a store, you can get an Infineon board with a vector HSM, you're going to be fine. You don't need C2A for that. We thought we can contribute in the active security measures. So having very unique and very high-performing network IDPS, operating our own proprietary algorithms in real time so we can handle 1 gigabit throughput of Ethernet while still complying with automotive real-time requirements. So that's where we have more expertise and more added value in the ecosystem. And same goes for our endpoint protection solution. So for one of the features that we have there is detecting exploitations in real time and stopping them. And that's something that wasn't available in the industry beforehand, the way we implement it. And we understood this is something that the industry needs, and we can implement it and contribute it to the ecosystem and provide additional security layer that is unique for C2A.
Fascinating. So I have follow-up questions there. So endpoint meaning, I assume you're saying inside the ECU you are doing that mechanism. That's the endpoint. When you say dynamically or real-time vulnerability detection inside the ECU, can you tell us a little bit more? What does that mean? And what is the mechanism there to do such real-time vulnerability scanning or vulnerability detection?
Right. So automotive real-time is a definition. right? It's about how much overhead you add as a solution, maybe a security solution or any other feature. So meeting automotive real time is usually less than 10 microseconds or 5 microseconds, depending who you ask. So it's about adding security and still maintaining the original code overhead, which we don't add more than requested. The way we do it is that we embed our own software on the existing ECU software. So when the ECU code is operating in real time, we monitor it and we can detect this malicious activity. Now, one of the special things that we did at C2A, which is unique to us, is that we're able to embed this solution also in safety environments. So usually doing such activities in QM environments is quite straightforward. Right? So cybersecurity-wise, it's straightforward. But when you try to do it in a safety environment, so let's say AutoSAR, for example, then you need to follow the AutoSAR methodology. And you need to make sure that you're not harming the current process, which the tier 1 or the tier 2 that wrote the code with and received the certificate for safety is not broken because some Israeli came and patched the binary. So we have our own IP and our own capabilities to do it. So integrating security into those safety environments is one of the special things that we're able to do.
Love it. So you mentioned safety security coexisting. I mean, I will come there. There are some frictions, as we know, between safety and security. So I will get there. Before that, you talked about also the standard, managing cybersecurity. Now, the standard, as we know in the current published draft, they talk about cybersecurity management, incident management, and all those. Let's have a look to the traditional IT security, infrastructure security industry, IT security industry. And we know statistically, and the statistics may differ, but about roughly 80% of the attacks are social engineered. Yeah. So technology is amazing, it's going to work, but the management part is really, really crucial. Is the standard going toward in the right direction in terms of social engineering? Of course, technology is going to help. Intrusion detection system and all these things are going to help even in social engineering. What is your view on the standard? Is the standard in the right direction for such things?
Two ways to answer it. So the first way to answer it is that our users, we cannot assume that we'll guide them, right? And we cannot assume that we can trust them because we cannot educate them. So when you talk about social engineering in enterprise, then the enterprise is going to try to educate his employees, right, and give them some tests. And actually, there are amazing startups, like training your employees for phishing and all that, because you try to minimize that attack vector. In automotive and actually in consumer, yes, because automotive, in a very weird way, it's a consumer market, eventually. We cannot rely on educating the users. So we're going to have to protect the users from themselves. So we'll need to assume that the user will cooperate with social engineering because he's naive or he's not aware of such attacks. And we need to protect the vehicle from the user. It's actually our perimeter solution is meant exactly for that. We say that the head unit is going to be compromised. Now, once we understand that, let's build a protection to protect the vehicle internal networks from that head unit, because that's going to be a risk. So it's different ways to look at the head unit. Now, if you look at the standard, and the cybersecurity management system that they're putting in place, and social engineering from the manufacturer point of view, I think one of the largest issues that OEMs have is visibility. What do you have inside your vehicle? I did a webinar 2 weeks ago about risk assessment. And why are you smiling? Because you attended the webinar?
No, I didn't attend the webinar. No.
And in the webinar, I had about 100 and something attendees, and I asked, how long does it take your organization to do risk assessment? And the most common answer was 4 to 6 weeks. And the reason for that, I can tell you that this is the main reason from all the meetings that we had with OEMs in the last year, is because they don't have good visibility. They don't know exactly what's happening inside the vehicle because of the nature of the automotive industry. Right? It has a very complicated supply chain. So you're going to get a gateway and an ADA system from different suppliers and a domain with some ECUs below it. So this concept of cybersecurity management system that is elaborated in the ISO standard, for me, that's the foundation for good cybersecurity inside the vehicles. Now, obviously, it's foundation and it's guidelines, and what the OEMs are looking for, some of them are actively looking for, and some of them here in their back mind they're looking for, is a practical implementation of that. And this is something that we are already working on. And so we'll launch it actually in about 3 to 4 months.
Practical implementation of what exactly?
Of managing the cybersecurity lifecycle. Because guidelines are fantastic, but if you try to implement that in a services manner, right? There are a lot of services companies that provide services to implement the standard or to implement best practices of the standard inside the organization. That's going to be very expensive, and it's very hard to scale that because eventually you need to protect the vehicle from the very first day you start to design it. Right, so let's say you have about 3 years until production, which you'll have to maintain the vehicle security, right? If you let's say that you selected some OpenSSL library, which we mentioned before, you selected a specific version 1 year before production or half a year before production, and a day before production, a vulnerability was published, and this library is now compromised. Then you have to release an update or change it a day before assembly line. Firstly, running all the tests and all that. That's a huge challenge that they are facing. And most of them are facing it right now, trying to meet the ISO requirements, and mostly doing it with services or in a non-scalable way. But for us, what we are seeing and we are very worried about is actually maintaining the vehicle security afterwards. Because once the vehicle is on the road, there's at least the guarantee period. We'll have to maintain the vehicle security posture. So if a new vulnerability is published or some incident happened, which could happen, then the OEMs will have to react quite quickly. So do risk assessment quickly, mitigation if needed, get the vehicles back to their secured state. So I think the cybersecurity management system is an important pillar. Still, there is a need for a practical way to implement it. And most importantly, we have to look the day after production. It's not only the 3 years from design to production, but we need to look further.
Yeah, I totally agree. That is the perfect segue to talk about what we wanted to talk about, safety and security. Now, you brought up some very interesting points. What you're worried about is not the development time. What you're worried about is once the vehicle is shipped, once is in the street. That's a very interesting point because we'll have to keep shipping over there updates or updates of some kind for zero-day vulnerabilities, exploits, and so on. If you look at the current vehicle architecture or the process, because of safety reason, you certify the code. Yeah, SOP means you freeze your code, right? And not only forget about security for now, even for future reason, we're moving toward autonomous era. Even for future reason, we see new kind of objects in the road, right? I mean, we have this kind of e-scooters in Germany now that we didn't see 5 years ago. We will have new road conditions, new kind of objects in the road. So for that reason, you will have to keep shipping updates all the time. The traditional way of development, in my opinion, it will be obsolete in one form or the other. Now the question is for safety. So there's this approach, I'm sure you know, that's this enveloped approach. So you have one part of the envelope, inside it, you put a safety envelope, and this is where you put your safety code, which you don't touch. And you have another layer where you keep shipping patches, updates, and so on. In terms of security, there can be question marks, there can be vulnerabilities even with this architecture. Yeah, how do you think this problem will be solved? You said that you're shipping a very practical management system pretty soon. So tell our audience a little bit about it. Pragmatically, how should we approach such issues?
Should I start with the bad news or the good news?
Yeah, sure. You start with the bad news, yeah.
The bad news is that it's not always solvable, right? Because as you
Agreed.
said, with that envelope approach, then there's some parts of code which it's either you won't be able to update or you'll try to avoid as much as possible, right? So only if needed, if there's no other solution, then you'll touch that code or update it. I think the good news is that you don't really need to update that even if there is a vulnerability published. I know I mentioned my webinar 2 weeks ago. I actually have a blog post on that. It's published online about risk assessment. I describe a very similar scenario where you have a vulnerability published in the AutoSAR implementation. It's a generic thing. I say one of the AutoSAR vendors had a vulnerability. Now, if you have a mature risk assessment process in place, then I show it through the blog how probably you won't need to patch it, because the possibility of an attacker being able to exploit that vulnerability is, first of all, very low, because we assume that the attacker has to be inside the vehicle, 3 legs inside, right? So bypassing the perimeter and bypassing the gateway and the domain controller, and then when he has the same network access, then he'll exploit that vulnerability in the AutoSAR chip. But second of all, if the attacker managed to do all that, he's able to do many other stuff, right? So I think the way to go with that is, if you have that cybersecurity management system in place, then you're able to handle those incidents in a more mature approach and say, sometimes we can leave it aside. Yes, there is a vulnerability there and the vehicle can live with that. So it's not the highest priority. I can fix it with time. I can decide not to fix it at all, actually, because to exploit that vulnerability, if the attacker is able to do that, he's able to do other stuff as well.
I love it. This is a very, very exciting exciting point that you have mentioned, because I get asked this question pretty often, especially from people from safety domain. They want to know an attack probability. There is no such thing as attack probability. I mean, we can definitely assign a number of such, like the annex of the current standard talks about cal level, but there is no such thing as attack probability. Now, you mentioned that, okay, if you have a vulnerability, probably it's not that likely. Feasibility is the right word, attack feasibility. So how do you quantify that, and how do you decide, okay, this is the vulnerability I want to live with? What's your approach for that?
The approach is really to understand what is happening. If you have good visibility over the vehicle topology, then you can play the hacker very easily. Because it's like a map, right, that you need to read. You look at the topology and you understand, okay, you have these barriers from the perimeter to the point of exploitation. You have this kind of security solutions, this network topology, and you can start to quantify it. Now, currently, there is no solution to give a concrete scoring, right, a number for that. The ecosystem is working towards that. So, I won't keep mentioning ourselves because we try to do that as well. But actually, I can point out the 5 Stars organization in the UK. I always give them a shout out because I think they're amazing. What they're trying to do is they try to create the equivalent of NCAP for a vehicle. So give some resilience scoring for vehicles. And we're in touch with them, and we try to give our inputs to the various partners in there, and we'll contribute as well in the future on our platform for that. There is a way to do it. For me, the way to do it, it's like the way insurance companies operate. Mm-hmm. Eventually, insurance companies try to do so, right? They try to give risk scoring, and accordingly, that's the business model, right? They build their insurance policy and the coverage, and they identify what should be the excess, right, and so on. So there is a way to do it. We can learn from other industries how to quantify risk by using building blocks and some basic questions or questionnaire on a vehicle topology. The key to do it is with visibility. If we're able to have good visibility as an OEM over our own vehicle, then we can have a mature risk assessment process. We can have a very good risk scoring mechanism built on top of that. And so it's not only good for OEMs to protect their own vehicles and to manage incidents, it's also good for the rest of the ecosystem players.
All right. So NCAP for automotive security, you mentioned this, if I understood right. That's going to be fascinating. That is again another amazing segue to get into what I want to get into: testing, security testing. That's the right side of the V model in the standard, vulnerability scanning and so on. Does your company provide any testing solution? Or before going to that specific, I want to ask you for generally, traditionally, what we see in what we have been seeing in the automotive industry is we have a requirement and we generate test cases for the requirement, requirement-based testing. When it comes to ADAS, we know that requirement-based testing is not enough. We had to design scenario-based testing, right? What is your opinion for cybersecurity? Do you think we can cover cybersecurity testing or validation and verification with a requirement-based testing, or should we go beyond requirement-based testing and do scenario-based testing as well?
It's a very good question. So there's a long answer. So first of all, I'll start by saying that at C2A we do not provide such services. It's a business decision completely. Services do not scale. And we, as a software startup, we look to scale. So this is something that we decided not to do. We do it internally for our own products, obviously, to test them. There are great companies out there that are doing it, and we're actually collaborating with such companies. Now, in regards to validation and certification, there are very strong players in the ecosystem, very smart ones, that are already doing similar things in other verticals. So I won't name them here because it's nothing published. It's been done already in other verticals, and something that we can do in the automotive industry as well. So I do think we can come up with a concrete mechanism to estimate the resiliency of a vehicle. The only thing that is missing to do it is infrastructure. Because if you try to give risk scoring for an IoT device, so a simple one, some kind of a meter, let's say, well, it's a very simple system on chip. The firmware is well defined, it's quite simple, it's limited. You don't have complex networks inside it. When you do it in a vehicle, first of all, the use case is much more complicated one. We have sometimes over 100 of ECUs inside a vehicle, different networks, different protocols, and there's a supply chain, right? You don't know exactly what you have inside it, although we do see OEM starting to require the source code of what you deliver even. So they like to compile their own code. They don't want to know exactly what you deployed inside the vehicle. But eventually we understand, and this is something that we took upon ourselves, we need to provide infrastructure so we can take similar concepts from cousin verticals and implement it for vehicles. So I think the concept is there, and some of it is public with the 5 Stars organization and other activities done in the UK. Saying UK because really amazing the kind of funding that they have through Zenzik there push such activities. And I think the infrastructure is what's missing right now.
Got it. So I think you mentioned two another stimulating points. One is the supply chain and one is source code. The supply chain is extremely complex in automotive. When it comes to tier 1, tier 2, tier 3, behind one vehicle, we're talking about approximately 3,000 companies. And source code. So without mentioning any name, I'm going to share one funny story with you that we were working in a project where this OEM demanded the source code from the tier 1. First of all, there was a long discussion, months after months discussion, they will not give the source code and so on. And the project was not going anywhere without the source code. Then finally, they sent us the source code. The source code was obfuscated. So the infrastructure, this whole thing is going to be difficult with the supply chain. There's no question about it. When it comes to liability issue, yeah, we can present a business case in front of the OEMs, in front of the tier 1s in terms of security. I mean, security, unlike your ADAS features or your infotainment features, you can't actually present a button in front of the customer where they click and another 5,000 euros for your BMW. That doesn't work. I mean, they expect safety and security to be built in. They don't want to pay anything on top. So it's hard to make a business case when you talk about liability. It's kind of like we can present a business case. In terms of such complex supply chain structure, supply chain landscape where the code is not even, I mean, I totally agree with you. Majority of the cases, the code is not accessible for the OEM yet. Yeah, OEMs are trying. What will happen in the future, we'll have to see. So in such a complex landscape of supply chain, who do you think should be liable for such incidences? And, like a company like yours, startup company like yours, will the liability go all the way down to you, or is it the OEM? Or when it comes to autonomous vehicle now, there will be a very different kind of services in companies like the fleet operators, some things that we haven't seen. There will be other roles now. So the landscape is gonna get more complex, not simpler.
Actually, I see it the other way around, because at the current landscape, there is a debate who's liable, obviously. Is it the gateway supplier if there's a breach in the networks around the gateway? Is it the TCU supplier if someone managed to penetrate into the TCU? The bad news for the OEMs is that the end consumer won't mind. It doesn't give. Yeah, it's VW or Ford that got the accident, right? I don't know who's the tier one behind it. I don't mind. I didn't buy anything from him. So OEMs are facing the consumers, and they are liable by the way of trade. So that's one aspect. And the second aspect, the way I see it, is that OEMs are the only ones that have the full scope of the vehicle. So let's say that I want to put the liability to one of the gateway suppliers, right? So right now, the gateway suppliers are usually the huge tier ones. So that's like good, deep pockets. If there is an incident tomorrow, they cannot do risk assessment because they don't have the full vehicle scope. Right? This process of what we described, of having a complex topology and looking at the safety ECU inside the vehicle and being able to say, okay, you have this and these measures from the perimeter to this internal network and this kind of topology, and having this mature decision of saying, you know what, we won't patch it, we won't touch it because actually the feasibility is quite low. Tier 1 cannot do it unless it's provided by the OEM the full scope of the vehicle. So it's the OEM. Yes, now the OEM can decide that he's going to use someone's services in order to do it, but it's still going to be the OEM. Yeah, so he can try to sue the cybersecurity supplier, but that supplier going to have to get from the OEM the full scope. It cannot happen in the current landscape where the OEM is asking for an IDPS for a gateway via an RFQ.
No.
In this current methodology, this cannot happen, right? The supplier of IDPS for the gateway doesn't have the full vehicle scope. Now, looking to the future, if you look at autonomous vehicles, and let's take the robotaxi use case, because you mentioned fleet operators. I think we understand that most fleets are going to be OEMs, right? We see Tesla and we see Mobileye. It's all public knowledge, right? They're publishing that they want to operate their own fleets. In that case, it's even easier because the OEM is taking full responsibility almost end to end, right? Is selling directly to the end user, the taxi, and he's operating it. So he's actually maintaining the vehicle while on the road. So from that point of view, I think OEMs taking responsibility for cybersecurity makes more sense, and maintaining, and also operating wise, it's easier for him because he still owns the vehicle, so it makes sense for him financially as well.
Totally agree. All right, so Nat, I asked most of the question I wanted to ask. Is there anything else you want me to cover?
You mentioned AutoSAR before, right? We joined AutoSAR organization as development partners several months ago. It was after we collaborated with Vector to integrate one of our security solutions to an AutoSAR environment. And it's also in there, AutoSAR is, I think when we started C2A, the company was established 4 years ago. And Michael and Isaac, they approached an AutoSAR vendor, I won't name him, and they said, listen, we found some vulnerabilities in AutoSAR, and I think you should look into that. And the response was, AutoSAR is a safety environment, not a secured environment. Our goal is to be safe, meeting the safety requirements and making sure that no one will die while using this operating system. And the year is 2020, and there is a group inside AutoSAR organization focused on cybersecurity. And about a year from now, a new spec will be published, and it will include a lot of infrastructure for cybersecurity, and all the different vendors are already preparing for that. It's nice to see that also in safety environments, the industry is advancing and is preparing to deploy security there as well.
I love the point that you have mentioned, and we are also active development member of AutoSAR. We contribute in Adaptive AutoSAR's security and the safety group. We are in both the working groups. And I have to tell you this, saying AutoSAR is not a security environment, it's a safety environment, is lack of understanding that safety is essentially a subset of security. I mean, how many times you have heard our safety colleagues saying, hey, I'm a safety guy, I have nothing to do with security. I cannot stress enough how wrong that person is. It happens even today, right? So, I mean, the standard clearly mentions that there are 4 consequences of cybersecurity, and one of them is safety. So you can kill someone with your attack, right? So there's no way we can say that this is safety, we don't care about security. That's the statement. What do you think of that? Do you also experience such thing? We wanted to talk about the friction between safety and security, and this is kind of like a cultural friction. And I think this is like, we have to go one step back and make people understand that when we're talking about safety, you're not outside of security. You have to deal with security. What do you think of that?
I completely agree with you. Actually, about a month ago, we did a webinar about aligning safety and security requirements. And I think doing that's basically the approach that we try to take to the automotive industry, is instead of coming with a hammer, and threatening everyone like, so cybersecurity, you're going to die, and all that. We try to look at the automotive industry and the way it operates right now and speak the same language. So show the safety, the functional safety personnel in the OEM, how a safety requirement is easily translated into a security requirement, which is then aligned. And by definition, they require some sort of security measure. I think that's a way to go. And we see the acceptance. In the webinar, most of the people that attended it were functional safety personnel, which I think are terrified about this cybersecurity topic, right? Because you mentioned before, how do you evaluate? How do you do all that? How do you give concrete scoring? In functional safety, there are a lot of good methodologies in place, but they are used to, and very rightfully they're used to it, because it's a very automotive approach, a structured approach. That's the right way, actually. Israelis, we don't have automotive industry. We didn't have automotive industry at all before the boom here. Right now, we have a nice ecosystem here. And I think we are getting culturally a lot of things to us from the automotive industry, because we learn how a structured process should look like, and how, looking at the OEMs, eventually they manage this amazing process, and they manage to deploy a vehicle at the end and have a car program. It's a crazy thing. Car program is so complicated. So I think the approach with that is really taking security and put it in the same lingo as safety, and show how it's aligned, and again, provide this infrastructure so it could be implemented. So take those guidelines from the ISO standards and take all this knowledge and put it in a structured way which could be implemented and aligned with the safety requirements. I think that's a way to go.
Love it. With that, I have one last question for you. We're moving toward an era where automotive industry is going to be disrupted and is going to change our life. It's not only an industry that's going to be changed, it's kind of like massive change in civilization, autonomous vehicle, connected vehicles, electrification of vehicles. This is going to change our society, our environment, and our culture. So with these disruptions coming up, we have problems. Obviously, we talked about it. Cybersecurity is going to be a problem. Besides the problem, what do you think, in your opinion, would be the most positive thing for us, mankind, humankind?
Great. So a non-cybersecurity question. I like it.
Yeah.
I think the quality of life will change dramatically. Us not owning a vehicle is a good thing. Yeah, so this flexibility, no need for parking space. It's a huge thing. I'm sorry that I'm looking at from that angle, yes, but I'm from the
Yeah.
user angle because I'm not planning to build an autonomous vehicle and loads of implications. We provide the supporting mechanism. That's not having to park. You don't need to own a vehicle with autonomous vehicles. This is the whole way I think a city is designed and built will change. And that's the most basic thing from my view.
Yeah,
Cities are going to change. It's enough.
I love it. Cities are going to change. We won't have to own a vehicle. We won't have to park a vehicle. With that, Nat, it was lovely having you. I love this discussion. And thank you so much for watching. If you have questions, comment, please write in the comment section. And we will love to see you in the next episode.